Hello, I need to build a new robot because this one we made Alpha doesn't work. The weapon speed controller's gone on it, so I want to build a new robot that doesn't have a spinner on it. I do have quite a list of robots that I could build, and I've already started models for most of them, but no spinners kind of limits me a little bit. My first thought was to rebuild my flipping robot, Rob Anybody, which I decided against for two reasons. One is that I wanted to try something new that I haven't built before, and the other is that I appear to have lost the previous version of Rob Anybody. I just went to look for it and I can't find it, so it's no real big deal, but yeah, so I don't really want to rebuild that. So my other next idea was to actually rebuild my axe heavyweight. So I've actually already built the antweight version of it before I started the build video, which is kind of weird. So there it is. This is my antweight version of Huntsman. I've actually called it Awfully Wee Billy Bigchin, which is yet another one of the pixies from Terry Pratchett's Discworld series, if you don't know. But this is pretty much a scaled down version of what Huntsman was. So here is the 3D model for Awfully Wee Billy Bigchin next to the model of Huntsman. So you can see the size difference between the two. So the 150 gram robot and the 100 kilo one. But I want to go over the designs, reasons for the way it's designed the way it is. I've always liked building axe robots. Axe robots are kind of my favourite robot. And I know it won't work in an antweight, but it's just fun to build and drive. And I've already tested this thing out and it works exactly the way I wanted Huntsman to work, which is awesome. But I've been building them since my original Scarifier robot back in 2004, 2005. The first weapon it had on it was a EV Warrior powered hammer. That didn't work, I never actually competed with it, but then my next robot after that was a pure axe robot called Avenger. The first version of Avenger looked completely different than this, and it looked the same at the same time. Basically, when I started the design, we had sealed lead acid batteries back then, which are a bit archaic now really when you think about it, but big 7 amp hour sealed lead acid battery in order to drive the hammer took up so much weight and so much space inside the robot. I basically had to put the whole back section of the robot stored for the battery and then the weapon motor in the middle, and then the drive had to go up the front because I took up all that space at the back. So the drives were at the front of the robot. And as you can see in the build video for Big Yarn, the latest one, where it tries to drive upside down with the wheels out here, having the wheels up the front of your robot does not work, and the bloody thing didn't drive very well. The other issue, which was when you swing the axe, the reaction torque from the motor onto here causes the nose to lift. Now it might only lift by a couple of millimeters, but that lifts the wheels off the ground, so while you're swinging you can't drive. Not that big a deal, but the main deal was the fact that it couldn't drive straight. So I then redesigned Avenger to have the wheels up the back, which really increased drive quite well. And that particular robot got taken to India, which won a competition. So it drove really well. It had a normal style wedge at the front with little claws out the front to try to grab the robots and stop the nose from lifting. Before I started working on Huntsman, I realised that wedges on the front of axe robots is actually a bad idea, and I'm probably the only person who thinks that. And I can prove it though. If you watch the videos of the latest season of BattleBots with Beta vs Nightmare and Beta vs Tombstone, both of those spinners right up the wedge of Beta and hit the weapon mechanism and disable it. Now that's a strong belief that I've had that the most weakest part of an axe robot is the mechanism at the top, and if you put a wedge on the front of your robot to try to get the other robots to sit on it while you swing the axe to stop the nose from lifting, all you're going to do is basically damage your own axe mechanism. So I actually designed my robot so that it had a fully armoured front, and I wouldn't allow the other robots up the front of the robot to damage it. I would like really heavy weapons on my axe robots. The weapon on Huntsman actually weighed close to 15 kilograms, which is quite a massive hammer. And with that, when it's swinging, because it takes a long time to swing, you've got a lot of torque at the pivot point, so you get a lot of reaction torque going through your robot, and the nose lifts quite a lot. And even with my featherweight versions, which had, I think the heaviest hammer I used was 2 kilograms, 2 kilogram demolition sledgehammer. Anyway, that causes the nose to lift quite a lot, and I took a lot of high-speed videos testing my robot showing how the nose lifts. And it actually exposes the underside of the robot quite a lot. So the idea was that to put a inverted wedge on the front of my robots so that when the nose lifts, it actually directs any spinners or anything underneath to a armoured underside, which protects the nose and allows the robots to hit. Also, one thing that I've noticed a lot with hammers, particularly with ones that I originally started designing, is that when it swings, most people design it to swing just over 180 degrees like this, so it comes out and hits something here. So they put a hard stop underneath of the robot here to stop the axe from swinging too far. I am, again, opposite style of thinking. I prefer my axes to continue swinging, because even if the nose lifts 30 degrees, if you stop your axe swinging here, it's going to miss whatever is here, hit the front of your robot and whack, lift the back up like that, and you'll end up boom, like that. What I prefer to do is to actually allow my axes to spin a full 270 degrees and allowing the nose to lift. That gives the axe more time to swing, and because it's an electric motor, the longer it takes spinning the axe, the more energy goes into the axe, therefore the harder you hit. Therefore a slower moving heavy weapon would inflict more damage than a faster, lighter weapon. So allowing the axe to swing further and hit the floor rather than hitting itself inflicts more damage on the other robots. Although technically lifting the robot reduces the amount of energy that's in the axe, it's still technically taken 180 degrees to swing that far, even though the robot's also lifted about 60 degrees. So it's still got the same amount of energy even if the nose doesn't lift. So you lose nothing by allowing the nose of your robot to lift. Also, if you drive up on a wedge, you can still whack the back of the other robot. You don't have to hit the front of them. So I don't see any problem with riding up over other robots, because that's what the robot's designed to do. Here is Avenger riding over top of another robot and still managing to hit it. Also, having the wheels at the back is handy, because when the nose does lift like this, you're able to still drive. Now, I actually submitted an application to go on Season 2 of BattleBots, and I submitted a heap of drawings to go with that application that showed how the robot would act like this. Here is the drawing from the application package showing the axe at 270 degrees and how the robot could still drive in this position. This robot is built exactly the same way. We have two motors in here, with the drive motors from Mad Arthur driving the wheels at the back. All the weight is in front of the wheels, so it drives nice and straight while driving forwards. We have exactly the same motor driving the axe. The only difference between this and Huntsman is Huntsman had two motors driving the axe, but this one only has one, we only need one. And it uses a speed controller, single channel speed controller to drive the axe. There is a slight gear reduction on the axe just because I was slightly worried it wouldn't be able to self-right. But I have tested this one, it self-rights beautifully. In fact, it gets a little bit airborne when it does it, which is exactly the same as Avenger. And here is Avenger jumping into the air at the 2012 National Championships. Huntsman actually managed to get airborne too while it's self-righted. It just never did while it was at Robo Games, so no one actually got to see it. So yeah, it is basically what I wanted Huntsman to be, and if Huntsman acted the same as this, I probably would have won a couple of more fights. And show you the quick montage of the design in Inventor on this thing, and then I'll show you how it actually drives. So the robot only took about 2 hours to draw. That was all the parts. I've kind of sped it up a bit so it's not so drawing, but you can see basically how I did most of it. I tried to keep the design as close to the original Huntsman as possible, just because I knew what the design looked like. I didn't want to do anything differently, but I tried to thicken up the outside edges quite a bit to protect the wheels at the back. It does have the extra motor mount here at the front for the drive, which is basically copied through. And I do copy through the sketches and wheels from the other robots so they're not redrawn. The gears at the front here are drawn using the design accelerator that comes with Inventor, so it does have an automatic gear generator, so I don't need to draw those from scratch. I just add on the extra bits to make sure it works. And this is what the finished design looked like without the top covers attached. So yeah, it came out pretty good. Here you can see how the robot drives. Pretty much just looks like every other standard amp weight with the drive. Nothing too special. And then here we fire the spoon, and you can see that does look pretty good. So it does go over pretty nicely. I don't think it'll do any damage. It's just a fun robot. You can see it jumps around quite nicely. It's going to be quite entertaining to drive, but yeah, I doubt I'll win anything. And here are the shots I recorded with the high-speed camera, so we can see just how much the nose lifts. As you can see, it's pretty close to 60 degrees by the time the spoon hits the floor, and the nose does rear up quite a lot. And then the robot pretty much almost goes right over when the axe returns. So you can see here the nose lifts about 60 degrees. The robot would still be able to drive in that position. And then when the axe retracts, it pretty much flips right over onto its nose. I don't know how much control we'll have when that's happening. There's a self-right, so with the axe in the retracted position, it actually flips itself completely over, and it only self-rights when the axe's spoon has already flipped. I keep calling it an axe, but it's a spoon. So it does roll over a lot. And this is a spinning test, so spin the robot and fire the axe at the same time just to see what would happen. The robot does leave the ground completely. So this is quite entertaining, and then flips back over, and a little bit of air while it flips back over. So I don't won't. So yeah.